Okay, so just to correct this mistake. So Aaron, your homework, you also wrote this down, but I actually made a mistake. Yeah, I was confused by 128 thing. So the question was base 3 representation that does not contain a digit 2, right? So we first convert that into a base 3 number, and basically just from 1 in base 3 to this number in base 3, we have to exclude every number that contains a 2 in it, right? So that's literally just 1 to 1, 1, 1, 1, 1, 1 in base 2, okay? And then 1, 1, 1, 1, 1 in base 2. So literally we're correcting a mistake we made from last week, okay? This number is not 128. This number is, well, the first one is 2 to the power 6. Second one is 2 to the power 5, 2 to the 5th, right? And then 2 to the 4th, and then 2 to the 3rd, and then to square this stuff, right? So actually, this is 2 to the power 2 to the 7th minus 1. How do we know it's 2 to the 7th minus 1? Because if you add 1 to this number, you would get 1, 0, 0, 0, 0, 0, 0, 0, 2 in base 2 minus 1, right? If you add 1 to it, you have to carry over in every digit, then you will get this minus 1. Make sense, everyone, right? So that means this 1 followed by 7 zeros, this is 2 to the power 7 minus 1. So this is actually 128 minus 1, so 127. So not this. Okay, I hope we clarify this. 这大家都没问题吧？这上节课当时没人看出来，当时我懵了一下，后来我就一直觉得不太对劲，我就课后看了一眼，然后我就发现这个错误很愚蠢啊，我犯的。Okay. So by the way, what is this? I know Ryan, you know what this is, right? Does anyone else know what this is? Like, say that I can also change 2 to 3. I can also change 2 to 4. This is called geometric series or geometric sequence, because the ratio between consecutive numbers is the same. They have a so-called common ratio, right? See if anyone knows. If you don't know, that's fine. You just, it's just what it is. Okay, but for Ryan, you know what geometric series is, and you also know the formula for it, right? You will see that the formula can also be proven. Well, if the common ratio is an integer, it can actually be proven in a number theory thing. 比如像这种 common ratio，如果是个整数的话，2的几次方，2的几次方，或者你换成3，或者你换成4，那都可以。其实也可以用这个看得出来，它也是用了那个 formula 的。But anyway. Okay, so and also this is Aaron's homework. So Aaron, here I made a comment to you, and right, this is, yeah, and yeah, okay. So let's talk about some homework questions we have in chapter 9, and also Lily, if you have finished your homework, and send them to me, okay? Maybe redo your homework. Any question you got wrong, you can redo them. All right. Area for this one. This is 9.3.1. The last question. 22 EE9. This is something we did last time. So you can check out our note here. Okay. So you got it wrong. Maybe you can have a look again and see why. Okay. When you borrow a digit, it's 16. It's base 16, so whenever you borrow one, you should add 16 to it. Okay, and remember the values of these digits. It shouldn't be too hard. So I'm just gonna cover questions I see we have problems. Rika, are you there?
Yeah.
Yeah, okay. So Rika, you made a mistake here, so I'm really confused. What do you think this number to be? This is addition. A. 1 in base 6 plus 5 in base 6.
10，
对啊，我 10 in base 6 right？ 我看你写了个2，很奇怪，好吧？可能你写错了，可能I don't know. But anyway, let's talk about this, okay? So here. So Rick, again, you said that you have problem with letters,
No,
right?
not addition，不是 addition 我会了，就是 addition 和那个 subtraction，就是那个乘除法能不能就是做一遍那个就是 like the whole procedure for 乘除？
哦，乘除法就是一定要换成 decimal，没办法。那这个我看你
要
作业里
画成
没有写啊。
这个没写吗？
你看昨天看的那 F 是漏在哪儿
那是我上次发的，我忘记补了。
？Okay. All right, then let's skip it. Here J and L. Let me
它
check
是怎
again.
么画成就 decimal 呢？
怎么换成 decimal 啊？那就是用那个 digit bundles 嘛，比如说都一样，比如说你 base 11那不就是有10啊，有1啊啥的嘛，对不对？
Yeah，
A 就是10嘛，然后换成，因为你是一个 digit 是换成 base 10，所以每个 digit 就是它对应的值就可以了，然后就乘完了之后再换回成这个 base。OK， 把这我待会给你再做2个示范，好吧？So Aaron, these two questions are the questions you made a mistake with. Okay, so L we did it last time, right? So you're gonna have a look, and for this one, you see in base 2, I don't know. Yeah, why I had a error there. So let's have a look at this. Let me check again. Yeah, you see, you're just missing by 1 digit. Okay, maybe just a very small mistake. Okay, Aaron. So maybe you can have a look at it. Just missed by 1. Okay. So yeah, so I'm just gonna skip it. It's not hard. Let's talk about multiplication and division. So multiplication here. 所以瑞卡，你是讲带字母，就是这个是吗？这个上一节课讲过，对吧？那你想再看一遍，行，然后我们再举2个例子，好吧？Okay, so Rika wants to see examples with letters and in multiplication and division. So let's do this again. So let's say 1, 9, 2, 3, AA. Okay, let's explain what we have to do here. So when we do this, for example, we do 2 times A, right? So so first of all, the general method is the same as we do multiplication in base 10, right? It just times this. 这个没问题吧，瑞卡？这个正常的 procedure 还是一样的，还是2乘 A， 那9乘 A， 1乘 A， 然后2乘 A， 9乘 A， 1乘 A， 对吧？然后写在底下 ，OK？ So first we do 2 times A. What is A? A is 20, so A is 10, right? So 2 times A so we'll first do 2 times A in base 10 and then convert it into base 11. So when we do this, 2 in base 11 times A in base 11, we first convert them into base 10, right? When you convert them into base 10, 2 is still 2, but A is going to be 10 because A is 10 in base 10. So that means you have 20 in base 10. Does that make sense, Rika? That make sense to everyone else?
什么意思？
就是2乘 A 怎么做呢？先把它换成 base 10嘛，对不对？换成正常十进制的 ，OK 吧？
对啊，
就是对吧？然后2是不是还是2啊？那 A 在 base 11里面是不是10啊？那是不是2乘 A 在 base 10里面是20啊？对吧？然后最后呢，我们再把这个 convert back into base 11。OK， 那怎么 convert back into base 11呢？你是不是有一个11，对吧？ 一个11，还有一个9啊，11加9是20嘛，所以是19 in base
哦
11。你想是不是？你
哦
19 in base 11，你想明白吧？这一块儿，它是不是就是1乘以11加上9乘以就是11的0次方，1乘以11的1次方？其实就这么想就行了，对不对？你先做 base 10的 multiplication，做完之后把它换回成 base 11，因为这些数都不大，这只是简单的乘法，一位数乘一位数嘛。所以当你变回来的时候，你可以口算的，就 mental calculation 就可以了，因为你是 base 11，直接就想20里面几个11啊？20里面有一个11，对不对？然后余一个9，对吧？这个就跟20除以11是一样的呀，20除以11的1，然后余9，所以是19。比如说，如果是
哦
30呢，那30就是2个11，对吧？余个8，那就是28嘛。等等等等，你理解我意思吧
哦
？OK，我们都把它做完啊。OK，这 2 times a 是 19，对吧？我们就写下，写一个9，然后 carry over 一个。OK，接下来是不是该做这个9乘 a 了，对不对？OK 吧？所以我们还是一样嘛，so 9 times a。So again, that's 9 times 10 in base 10, 90 base 10。大家都没问题吧？So 90 in base 10, 90 in decimal system, right? And then you have to convert it back to base 11. So again, how many 11 are there in 90? So obviously 8, right? 88. So we say 8, and then the remainder is 2. So 8 2 in base 11. Again, this is 8 times 11 to the first power plus 2 times 11 to the zeroth power. 瑞克，你看这地方有没有理解？
能理解，就是要先，就是正常乘法，然后呢把这个，比如说2乘 a 或a 乘9，要换算成11的 base，
对，不换算成10的 base 啊，这都是10的 base。你看我这
10的啊，
个没有写，
对对对，
对，这是我们
10的 base，
正常的乘法，哎，然后换回来之后呢，
然后再精制，然后再算。
对，就是在十进制里面，正常我们世界正常的十进制世界中算完了之后呢，再换回成它的 base number 就可以了。然后换
哦，
的时候就是口算，因为这个数字比较小嘛，因为你做乘法只会有一位数乘一位数，对不对？一位数乘一位
嗯
数这个数字并不大，你在换的时候呢，直接做除法就可以了，因为本来相当于就是你看有几个11嘛，就把几个11算出来。如果是什么，
嗯
如果是其他 base，比如说 base 15，那你就直接除15，看有几个15就行了，对不对？
嗯
那就这样就可以了。OK，会了吧
嗯，
？OK，看大家还有没有别的疑问啊？Anyone else have any other questions? So 9 times a, this is 90. In base 11, it will be 882, right? And remember, we carried over 1, so 82 plus 1, that's 83. So write down 3 and then carry over 8. Okay, and then 1 times a. 1 times a is 1 times 10, just 10, right? Just 10. So 10 plus 8 is 18 in base 10. And for 18, you have to convert it back to in base 11. So there's 111 in base 18, and then the remainder is 7. So 17, right? Let's write it down. 1 times a plus 8. In decimal system, this is 10 plus 8, so 18. And you convert it back to base 11. So there's an 11 in it, right? 111 in 18, and you have a 7 as a remainder. So 18 in base 10 is 17 in base 11. So you write down 17. OK，这样子就可以了，没看没问题吧？And then 192 times the middle A, that's the same. So 1739. And then 192 times 3. Okay, now we can do a mental calculation, right? So 2 times 3, that's the same because Rick 看这里啊，so 2 in base 11 times 3 in base 11, that will be just 6 in base 11. because if you convert, yeah, both of them into decimal, that's still going to be 6. And in base 11, it's still going to be 6, right? In other words, 2 times 3 is just 2 plus 2 plus 2, right? It doesn't really matter if you do this in a decimal system or in a base 11 system. This is always going to be 6. It's only going to change if you have a base number less than or equal to 6, right? If you have like base 5 or base 6 or base 4, it's going to have a effect here, but for this it doesn't. Okay, good. So 2 times 3 is 6, and then 3 times 9. 3 times 9 is 27, right? Just do 27, and then you convert it back to base 11 and do division, right? 27 divided by 11, there were 2 11 in that, remainder is 5. So that means it's going to be 2 5. So put 5 here and carry over 2. And eventually 1 times 3 is 3, plus the 2 is 5. Make sense? Okay, so try to remember this division stuff, right? You will see that when we convert any decimal number into, say, base number 11, base 12, or any other base, we basically do a division, right? So 20 divided by 11, 90 divided by 11, 18 divided by 11, whatever, okay? And the remainder is actually going to be the unit digit. Do you guys see this, right? So a couple of more examples. Let's say we do just using letters, right? Let's say we do base number 16, okay? A in base number 16 times, I don't know, D in base number 16. Just do some more examples, okay? 可以看，没问题吧？ Do some more examples. Observe the pattern, okay? Observe the pattern. So A is actually 10 in base 10. For D, A, B, C, D. So that's 13, right? A is 10, B is 11, C is 12, D is 13, okay? So D is 13 in base 10, and this will give you 130, right? But you have to convert this back to base 16. So you're gonna ask yourself, how many 16 are there in this number, right? Okay, so let's see, 16 times maybe 7, that's 2, that's 112, right? 112 plus another 16, 128. So 16 times 8 is 128, right? So we use 8. Now, there were 8 16s in it, and the remainder is 2, right? So we say 8 2 in base 16. In other words, it's going to be 8 times 16 plus 2. So always, yeah, so basically every time we do a division, and you will see that the unit digit is actually just the remainder of the division. 有没有疑问？这个个位数啊，其实刚好是这个除法的 remainder，看到吗？ And this will be the theme in chapter 10, actually. Okay, and this lays the foundation of what we call modular arithmetic later on. 啊，这要注意啊，这个 pattern 其实我是准备之后再讲的，因为这是个非常重要的 pattern。你做除法的 remainder，刚好是在转换 number system 里面的 unit digit，然后这个就很有用了，这个是可以帮助我们研究很多数学问题的，也是我们之后的核心内容，也是 AMC 考试的核心内容，就是在考这个东西。我们会学一个新的符号来表示这个事情。长成3个杠，这马上在 chapter 10 chapter 11就知道了。OK， 好。Let's say we get just one more example, last example. Okay, last example. Let's say we do C in base. Let's use a different base. The base different from any base we've used before. Let's say we use base 20. Okay, C times EF H. Okay, just like this. So first, always you convert it back to decimal system. Okay, so A is 10, B is 11, C is 12. Right? D is 13, E is 14, F is 15, A, B, C, E, F, G is 16, H is 17, okay? H is 17. So you do 12 times 17. I'm just going to use a calculator here. This is 204. Okay? And then again, when you convert this back to base 20, you just ask yourself, how many 20s are there in 204? And obviously 10, right? 20 times 10 is 200. So there were 10 20s, but you cannot write down 10, right? In base 20, 10 is A, is a letter. So you write down A. Make sense? And then the remainder is 4. So A4 in base 20. Okay, so Aaron, Rika, Billy, make sense? Right? Right? 没问题吧？你看一下这个 example。So A is actually 10 and in base 20s，所以你看204是100乘20加4嘛，对吧？所以10乘20加4嘛，对不对？那这个10呢，在 base 20里面你要写成 A，不能写成10，因为你写成10就会变成104，那就大了去了。因为104呢，那个第一个1是20的平方，对吧？然后后面的0，然后再加个4，那就变400多了。OK 吧？所以呢，这个地方就注意它这里是个10呢，你就写成 A，然后 remainder 是4，然后4就在后面。然后瑞克感觉怎么样？可以吧？All right，OK good。好，大家没问题，我们就继续啊。OK，Lily，看你有没有疑问啊？So this is multiplication and we do division. So division is basically like multiplication. You just have to multiply and then and try the correct answer, right? Where's division? Division's here. No. Where's our division stuff? Here. 瑞凯，你觉得这个 division 你还要不要再看一遍啊？因为 division 其实在做乘法嘛，要是吧？我们自己写一个吧。Okay, we just name one by ourselves. Let's say we do base 16 again, and let's have a bunch of numbers here. A, B, C, D, F. Just making up a random number, and let's divide by. 瑞克，你想 divide by 几啊？给我一个数吧。瑞克来给我个数，除以几？
9。
除以9是吗？
嗯。
一位数比较简单啊。好，那我们来吧。If we were divided by single digit, that's the easiest scenario, right? So first, just one by one, right? How many nines are there in A? 你看，正常做除法是不是这么除啊？我们先看看第一位数够不够除9嘛？就是问说第一个数里面有几个9。然后如果说第一个不够除的话，我们就写个0，然后就搞2位数除以9，不行了我再除以3位数除以9，就跟我们正常做除法是一模一样的 ，OK 吧？那你既然选了个9的话，我这边改一下，我把这里改成一个6吧，这样可以使，这样子我看一下，那好像也没用。我把第一个数改一下，好吧，这样怎么？这样也不行啊。等一下，我想一下，我把这2个数改一下，这样我可以让你看一个特例，不是一个特例一个情况，就是比如说这里是个放个8，那这里放个啥都可以，那放个7吧。好，换成8和7 ，OK， 这样子我们可以看到一个特殊情况，然后就搞明白就行了。All right, so first, how many nines are there in A? Anyone? How many nines are there in A? A is 10, right?
One.
One. Yeah, there's only one 9 in 10. 没看没问题吧？ So we put 1 here and we put 9 here. We do a subtraction. So A minus 9 is just 10 minus 9 is 1. 没问题吧？ Okay, and then we drop the 8. So we drop the 8 here. And how many nines are there in 18?
Two.
2, right? Wait.
No,
It's in
it's
base
not.
16,
It's
right?
more like
Yeah.
16 plus this, so it's still like 2, but like it has a remainder.
Yeah. So notice that this 18 is not just 18, it's 18 in base 16. Okay, very good. 大家注意到了 right? So this 18 here in 16 is actually 16 plus 8. So it's actually 24 in base 10. OK，瑞卡，你看啊，每一步都要把它换回成 base 10来做，因为你在 base 16里面是没有 multiplication 的，好吧？So 24 divided by 9, so that will be 2, and 2 times 9. Again, 2 times 9 is not 18, right? It's only 18 in base 10, but here we're doing in base 16. So 2 times 9, so I'm going to write down here, 2 times 9 is 18, that's base 10. You have to convert it back to base 16. So there's 1 16 in it, and remainder is 2. So there'll be 1 2 in base 16, correct? Okay, Aaron, that makes sense? Yeah, so Rika, 你觉得 make sense 吗？这里就是每一个，你看我29是做乘法，我18除以9，其实就是在做一个乘法嘛，因为我只要算这个18里面有几个9，有几个9就做乘法，只不过是要注意每一次我们做完 decimal 之后要换回成 base 16就好了。这个18也得是 base 16的其实24啊。那么这边换成12之后你写 so 1 2 in base 16, right? Just to clarify, we write everything, we write a 16 here. And then we'll do a subtraction. This is obviously 6 and drop the 7. Okay, and just keep doing this. So 6, 7 is in base 16. That's 6 times 16 plus 7. So that's 96 plus 7, 103. Okay, and then again, how many 9s are there in 103? Now, this is decimal. Okay, this 103 becomes decimal, right? And this 9 is also decimal. I mean, if it's in 16 or it's in decimal, doesn't really matter. So 109, 103 divided by 9, how many? 11, right? There's 99, yeah? Okay, so we get 11, 11 would be A, B, right? So we put down a B here, and again, 9 times B, if you're in base 16. In base 10, that's just 9 times 11, which is 99. So 99, so we're doing this B times 9, okay? B times 9, 99, you have to convert it back to number, like base 16 system. So base 16, how many 16 are there? 6, right? 6 times 16 is 96, and the remainder is 3. OK, 瑞卡看没问题吧？99换回成 base 16嘛，有6个16，那是96，还差一个3，对吧？就是63 in base 16, and you write down 63 base 16. 我写一下，这里是 b times 9出来的 ，OK，9 times b 给到你这个数，没问题吧？Okay, and then you have 4, you drop the d, and just carry this on and on and on. Gary 看你看有没有什么疑问？包括这个4D 也是 ，again， 它是 base 16，你把它换回来，好吧？换回成 decimal，然后做除以9就可以了。
换成 decimal 就是
decimal 是十进制的意思。
哦，
对 ，decimal 是十进制的意思，不是说小数啊，小数当然也是，对吧？所以4D in base 16的话，换成 decimal 是不是 4 times 16 plus d is 13呢？那就64加13咯，是不是77 ？Okay, and again, how many 9s are there in 77? 那69，7 9 63，8 9 72，对吧？那我们就放个8在这儿 ，OK? So 8 times 9 is 72. Now, notice that you don't have to convert this 8 times 9 back to base 16 every time, because you can also do it in decimal system, right? We know that 8 times 9 is 72, so you can also just write down a 72 here, because we know it is 72, which means that the remainder is 5. 那看这有没有疑问？就是这一步啊，你并不一定每次，比如说你现在不是知道了8 9 72吗？按说你要先换回成 base 16，然后再做一个减法，对不对？但其实也没必要啊，因为你已经把这个4D 换成了77了，换成了 base 10了，对吧？所以这个8跟9呢，你可以直接写个 base 10在这儿，然后这里77减72是不是直接得到5啊 ？remainder 只是5 ，right? In other words, 4D in base 16 minus 72 in base 10, and that's going to be 5. So you don't have to convert this back to number base 16. But even if you do, you get 5. You still get 5. Okay, because 72 in base 10, you're going back to 16. That's 4, right? 4 times 16 is 64, and then remainder is 6. So 4, 6 in base 16. So notice that I'm gonna write down here. If you do 8 times 9 in base 16, that's going to be 4, 6 in base 16, and you see D minus 6. 怎么不对啊 ？Sorry， 我看看啊，64加几啊？是48，写错了，对吧？64加8是72。Okay. So actually for 8. It's actually for 8, right? And 4D minus 4D 是13嘛？13减8呢就是5。OK。但是呢，这个48 in base 16 is actually just going to be 72. So we say you can do it in decimal, you can do it in base number 16, because we're getting a remainder. The remainder will never exceed 16, right? So you can just do it in decimal. 这样对吧？好，所以这里是一个问题啊，你并不是每一次一定要 convert 回 16 的，你也可以直接用 decimal 这边相减，是因为你这边找的是 remainder 对吧？因为你每次是拿你这个数呢除以它本身的数，然后找一个 remainder， 这个 remainder 是一定会比 base number 小的。那因为呢这样才叫 remainder， 如果比它大，比如说这边你得到了一个17，那说明你要多加一个16嘛，多拿一个16上来，对不对？OK 吧，所以你不会得到比一个 base number 大的数啊，你比它大的话，你肯定就前面多一位了，对不对？所以呢，你得到这个数一定比 base number 小呢，你就可以直接用 decimal 相减，没关系。因为平时我们去做，比如说 base 16，我们不能直接换成 decimal 减完就完事儿了，是因为这个答案有可能比16大，你还要把它变回来。但是我答案比16小，你就不用变回来了嘛。当然，你要是变成10啊，你要写 A 11，你要写 B 啊，你不能就直接写11、10，对吧？是这样子就可以了，然后再 drop 这个 E。好，瑞看你有没有疑问？我觉得这样做应该很 make sense 了吧 ？OK， 好，那 Aaron Lily 没问题，我们就过了啊。Okay, good. So we're gonna move on to review problems, and I don't think anyone has done any review problems except Rika. Yeah, only Rika did some. So 你看 Rika 你的有什么问题没有？And then we can move on to the next chapter. So, Rika, you did 1, 11, 12, 13, 14, 15, 16, 17, 19. Okay, good. So Rika, there's only one problem, and that's this one. Okay. To determine which of the following is are multiples of 12. A, B, C, D, I got them right. Just the last one. Okay. So the question is to determine if this is a multiple of 12. Okay. Right now, is a multiple of 12. 12. You just divide it by 12, right? So you have to do division and check. So C10B in base 13. When you divide it by 12, there were two ways. So a harder way is actually to do it in a base system, because to do it in base system, every time you have to convert it back to a decimal system, right? So there'll be so-called a hard way. Then 12 in base 13, that's A, B, C, right? So you divide by C. You can do this, or notice that you can always convert this number back to decimal system and then divide by 12, right? 是有两种方法，好吧？你要么就把这个换回成 base 10，然后除以12，这就简单一点嘛，整个过程中比较简单了。要么呢，你就把12换回成 C， 然后在这里做这种 base 的除法，这样会稍微麻烦一点。OK， 但是呢 ，but we see a C and C here and 1 0, so it seems like it's not that hard to do. Okay, so let's do it again as a practice. Okay, if you don't really want to do this, you convert it back to decimal. So here we get a 1 times C is C, right? And I get 0, so you drop the 1. And there, notice that there's no C in 1, right? 所以看没问题吧？没有 C in 1嘛，对吧？一肯定除 C 除不动，所以上一个零没问题吧？ We get a 0 here, okay? We put a 0 and we drop this 0 here. Remember, this is not 10. This is 1 0 in base 13, which means you have a 13 here, okay? C is 12, so you're gonna put another one, and you're gonna subtract a C from 1 0, which is 13, or just 1 0 minus C, obviously is just a 1, right? And then you drop the B, so 1B. Again, this is in base 13. So 1B divided by C, that would be 2. Because here is actually 13, so 1 times 13 plus B. B is 11, right? So you see this is 24. And remember C is 12, so 12 times 2 is 24. And this is just going to be 1B, and remainder is 0. So that means this number is actually a multiple of 12. It is divisible. Okay, guys? And also 1B divided by C, you can immediately know that it is 2. If you remember the pattern in base number, like we said that in decimal system, if you look at the multiplication table of 9, there is a clear pattern, right? 1 times 9 is 9, and then 1, so 0, 9, 1, 8, 2, 7, 3, 6, 4, 5, 5, 4, remember? You have this clear pattern, right? You have the same pattern in every other number system if you look at the multiplication of the number 1 less than the number system. So for example, in base 13, the multiplication table for 12, which is C, is going to be 1 times C is C, which is 0C. 2 times C is actually, you increase you increase the first digit by 1 and decrease the unit digit by 1, so 1B. 3 times C, 2A. 记得这个 pattern 吗？大家在十进制里面啊，你看9的乘法，它是不是有一个 pattern 啊？就是每一次都是10位数加1，个位数减1吧。所以从09变18变27变36嘛，对不对？之前我们看过这个 pattern， 大家还记得吧？就是在任何一个 base system 里面，如果比这个 base number 少1的话，比如说13里面就是12，你做乘法其实就也有这个 pattern， 跟9是一样的。4乘 C 就是30嘛，记得吧 ？A 减1是0啊。然后5不是 A 减1是0， 39，我在说啥呀 ？OK， 然后5乘 C 呢就是4、8等等等等。OK， 有2个最常见的 pattern， 就是 in a base system, if you time by a number less than that, you have this pattern, and also if you just time by the base number itself, so say 1 times 0 is just going to be 1 0. If you have 0, you still have trading zeros, remember? So even if you have 1 0 times 1 0 0, that's just 1 0 0 0. You don't have to convert back to decimal. Okay, and even if it convert it back to decimal, it makes sense. 1 0 in base 13 is 13. 1 0 0 in base 13 is 13 squared, so you get 13 cubed, and 13 cubed in base 13 is 1 0 0 0. Right? This is in base 13, okay? In base 13. 好，其实是2个 pattern， 对吧？所以乘以 base number 自己，也就是带0的，很简单。乘以 base number 少一个呢，那就是9的那个 pattern 也很简单。其他的呢就没有什么好的 pattern 了。好，来看有没有问题啊？没有问题的话，我们就看下一个 chapter 了。OK。 Okay, next chapter is all about units digits. The essence of this chapter is that it's actually just what we mentioned. In different number-based system, the units digit is actually just a remainder when the number is divided by that base number. Okay, but we will gradually discover this pattern through some examples. So we first look at some units digits in base 10. Okay, so question A, this should be very easy. So because these are just in base 10, okay, these are decimal. So find a units digit of each of the following, explain any pattern. So let's have a look. Do you see any pattern?这个应该很简单，这个 pattern 来看一下，然后告诉我们每个数都是8加9，对吧？这个 10.1 the pattern is obviously that everything has a unit digit of 7, right? And because this is decimal system, so it seems rather automatic, okay? But if we think about why do we have that pattern, is simply because it's in base 10. So because 8 plus 9 in base 10 is 17. And because we are in base 10, we have to minus 10, right? The sum of 8 and 9 is greater than 10. And since we are dealing with it in base 10, we have to minus 10. And you will see the units digit is 7. Okay, as a units digit. 没问题吧? Okay, so this tells you how to determine units digit in other number system. You add the units digit or subtract the units digit. And if the result is greater than that, is greater than the base number, you're gonna minus that base number. OK， 各位看你听明白没有？就是这个地方8加9是7嘛，这个谁都知道。但是8加9其实是17，那么之所以它的个位数是7的话，是因为你要减个10，因为你是十进制，你8加9是17，17比10要大，对吧？所以不可能说你的 unit digit 是17嘛，所以你减掉你的10就可以了。所以这个就告诉你说，如果在其他的 number base 里面，你要看 unit digit 的话，你把它加啊或者减啊，不管怎么样，或者乘啊除啊，假设最后这个结果是比那个 base number 要大的，比如说你在 base 12里面做出个结果比12大，或者在 base 5里面做出个结果比 base 5要大，那你就要减掉个5或者减掉个12，从而把那个 unit digit 找到，没问题吧？应该非常简单啊，我们过了啊。And this is clearly very easy, okay? Units digit, you just need to add the last digit, 没问题吧？ You don't have to add everything. 这个很明显嘛，对吧？只用减 units digit 啊，只用加减 units digit。所以比如说这个2加6是8啦，这3加6是9啦 ，right? 2 plus 9 is 11啦，就是 1了，对吧？我就加就可以了。Same stuff, okay? To find a units digit in subtraction, you just need to do a subtraction here, right? So 3 minus 9, that's not enough. You borrow 1, it becomes 13 minus 9, right? So 3 minus 9, not enough, it's negative. So you have to borrow 1. And since it's in base 10, so when you borrow 1, you're actually borrowing 10, right? And that means you have 7. So the unit digit will be 7. Okay? So that means in other number-based system, if you do a subtraction and the result is negative, then you have to borrow 1. You have to add that base number. Okay, add the base number. plus the base if you have a negative difference. 有没有问题哈？ Okay, and these, I think that will be easy. Yeah, just unit digit is easy. Okay, for multiplication, that's the same. Okay, you only need to multiply the unit digit. That's kind of obvious, right? And since in base 10 is very easy, so you multiply it. Here you have a 12, and again you need to minus 10. But remember that in other number-based system, you also just need to multiply the unit digit. In the other number-based system, when you do multiplication, you have to convert them back into base 10, right? And then you convert them back into base 10, and then you have to convert them back into their number-based system, and then you can look at a unit digit. 好，这些东西就 do you guys have any question here? They're in base 10. I think they're pretty easy. I'm gonna skip. Just time the unit digit, right? Okay. All right. Okay, if that makes sense, we're gonna look at 10.7. So because this is exponentiation, let's find out some pattern here. Okay. So let's first look at ACEGI. Okay, if you look at the first row, they are just powers of 4. Okay. If you need to find the unit digit of powers of 4, is there any idea? Does anyone have any idea? For 4? If you want to determine the unit digit of anything like this, what do we do? Nothing? Okay.
Turn it to base 2, to a base of 2 to the power of something.
But these are base 10, and we need to find the unit digit of them in base 10. Okay. So
no, I meant the base as an exponent base to 2, because 4 is a multiple of 2. Then we can actually use the base of the exponent 2 to determine.
Oh, okay. We don't have to do that. Okay. Remember, you call that in multiplication. If we need to find a unit digit, we just multiply the unit digit, right? But exponentiation is just multiplication. So we just do what we did in multiplication. OK， 瑞卡没问题吧？乘法的时候你要找个位数，直接把个位数乘它就行了，对吧？这个是前面的 example，就是这里嘛，这些东西对吧？你这些数虽然
它不是会重复吗？如果要算的话，它不是一直重复吗？4。
对，但是你只用乘个位数，对，4、6，然后呢
？4、6、4、6。
对，就4、6、4、6就出来了，对不对？Yeah， 你只用乘个位数嘛，对吧？OK，very nice，就是这样。So 4 is 4. 4 squared is going to be 6. Now, 4 squared is actually 16, right? But now we are only interested in its unit digit. Its unit digit is 6. So we have a special notation for it. Okay, special notation, guys. If you need to notify the unit digit, we use this. Instead of an equal sign, we write down this. Okay, 3 bars. 3 bars. And then the unit digit, 4 squared is 16. So the unit digit is 6, right? So 4 squared is 6. We use this notation. This notation is read as is congruent to. Is congruent to. Or you could simply say has a unit digit of, right? Has a unit digit of. Okay, so we say 4 squared is congruent to 6. And 4 squared has a unit digit of 6. Whatever. Make sense? Okay. So let's look at 4 cubed. Now, we first do this. So you could say it is 4 squared times 4. So it's going to be 16 times 4. So obviously, the unit digit is 6 times 4, which is 4, right? Okay. And now we'll see a very good pattern, right? So we say that we see that 4, the unit digit is 4. 4 squared, the unit digit will be 6. And for 4 cubed, the unit digit goes back to 4. So that means if you time by 4 again, it's going to be 6 again, right? Okay, Aaron, that makes sense? And Lily? So the pattern of the unit digit for powers of 4 is really nice. Just 4, 6, 4, 6, 4, 6, like this. When you have an odd power, you have 4. When you have an even power, you have 6, right? So we will automatically know every answer. So the first one will be 4. Second one here will also be 4. Because even for 24, that's the same. You only need to multiply the unit digits. So 4 times 4 times 4. Ignore the 2, right? For even power, you have 6. For even power, you have 6. Sorry. And for odd power, you have 4. Odd power, you have 4. Even power, you have 6. 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 Okay, make sense? So you will see that in multiplication, the whole idea to find out the unit digit is just to multiply the unit digit only, right? All the tens digit, whatever digit, we ignore them. Make sense? Okay. So that means we can also, to show your work, sometimes you can just write down this. I'm gonna show you. So we know that 4 squared is 6, right? It's congruent to 6. Say that you're gonna do 4 to the 4th. Then 4 to the 4th, you could say, it is first equal to 4 squared times 4 squared. And then it is congruent to, 4 squared is congruent to 6, right? So 6, and another 4 squared is also 6. And 6 times 6 has a unit digit of 6. You see, you can use congruent throughout. And even if for the first one, you can use congruent, doesn't matter, because they have the same unit digit, right? They are actually equal. Okay, try to make a note here. What about 24? Let's say we do this. We do 24 to the power of, say, 100, okay? So first, we say this is congruent to 4 to the power of 100, right? Because when you need to find out the unit digit, you just need to multiply this for 100 times. You don't have to multiply 24 by 100 times, right? This 2 could be gone. This 2 doesn't really matter here. So we say 24 to the 100th power is congruent to 4 to the 100th power, meaning that they have the same unit digit. And then it is congruent to, so 4 squared to the 50th. Okay, the reason why we choose 4 squared is because, well, 4 squared, we have a unit digit of 6, and 6 times whatever is 6, right? Okay, and 4 squared has a unit digit of 6 to the 50th, and we know 6 times whatever is always 6. So the answer is 6. Okay, see if that makes sense? Just notation-wise. Okay, this is also what should happen in your mind, right? When you see 24 to the 100th, you need to find a unit digit. You just need to look at the last digit. And look at the last digit. We know 4 squared is 6, and 6 times 6 is always 6. So, we know that eventually we have 6. Okay, so we go from this pattern. Okay. Aaron, do you need to go to the washroom, or are you still there? Okay.
Yeah, I'm still here.
Yeah, I'm just see. Just want to see if you want to go to washroom, we can have a break. Okay. If you don't have to, then we just finish last 2 problems and we have a break. Okay. Let's look at the word problem. So the product of 2 positive integers has a unit digit of 3. One of the integers has a unit digit of 7. What is unit digit of the other integer? Shouldn't be hard. Does anyone have any idea? 7 times what is 3? One integer is some
9.
number. Yeah, times 9. Good, yes. So a number ends with 7 times another number should give us a number ends with 3, right? So obviously 7 times 9 is 63, so it has to end with 9. We don't have anything else, 对吧？OK， 7、2、7、14、3、7、21、4、7、28、5、35、6、7、42、7、7、49、8、8、7、8、56，只有7、9、63。OK， so that means it has to be a 9. Okay, so no, that's it. Very easy. Okay, next. Karen is a teenager. The square of her age is equal to the number on her street address. If her age and the number of her on her street address have the same unit digit but do not add up to a multiple of 10, how old is Karen? Basically, it's asking that the square of a number has the same digit as the number itself, right?非常好。OK, Rika 已经给我答案了 very nice, yes. Okay, so the square of a number has the same unit digit as the number itself. So what this number can be, this is a teenager, right? So this number, let's say her age, since she's a teenager, has to be between 13 to 19. Okay, right? Teenager 就是说在 13到19之间啊，所以它有个 teen 在这嘛，对吧 ？Teenage 就是它的年龄呢是个 teen， 年龄是个 teen， 就是它年龄是个 13、14、15， 以及到 19。OK， so teenager means between 13 to 19. So which number among them has a square of a unit digit of itself? You could see, so you can write down this. 13 squared has a unit digit of 9, right? So it doesn't work. 14 squared has a unit digit of 6, doesn't work. You will eventually see that 15 squared has a unit digit of 5, so this works. 16 squared has a unit digit of 6, this also works, right? And 17, they don't work, so I'm just gonna skip them. You will easily see that they don't work, right? 7 squared is 9, 8 squared is 4, 9 squared is 1, okay? Nothing works. So only 15, 9, 16. Good. 瑞克，你看你给我15、16，对吧？非常好。这也不是15呢，就是16，对不对？ Good. Okay. Now, before we take a rest, I want to expand on this pattern. Okay. So actually, the unit digit. So for the unit digit of powers, if you change the base number to any other number, you will always see this kind of cyclic pattern. Whatever number you choose. Okay. So you can do it on your own. So you always have cyclic, meaning that they cycles, okay? They cycle. You have cyclic patterns for any power, okay? Any like power in any number, with any base numbers, okay? Maybe I should specify. So for powers of any number, okay? So say that you can choose 5. Then 5 obviously is always 5, right? So it's very easy. So the cycle is only 1, you could say. What about 2? So 2 squared is 4, right? 2 cubed is, well, 2 squared is 4, so 4 times 2, and that's going to be 8, right? 2 to the 4th, that's going to be 2 cubed times 2. And we know 2 cubed is 8, so 8 times 2, that's 6. And 2 to the 5th is going to be 2 to the 4th times 2. And we know 2 to the 4th is 6. So 6 times 2 goes back to 2 again. You see? Pattern. 2, 4, 8, 6, 2, 4, 8, 6. 2, 4, 8, 6, 2, 4, 8, 6. That's for 2. Okay? You can choose, let's say, 7. Okay, anything like this. You will see eventually there will be in a cycle. The reason why they will be always in a cycle is very straightforward, because you only have those many digits, right? In a base 10 system, you only have 10 digits, 0, 1, 2, 3, all the way to 9, right? 0 to 9. There has to be a time where you run out of all the digits, so you eventually have to start a cycle, right? So there's always going to be a cycle. So 3, let's just write it down. So 3 times 3 is 9, 3 times 9 is 7, 3 times 7 is 1, 1 times 3 is 3, you see? Cycles. Okay, for any number you can try. They're always gonna have a cycle. Okay, yeah. So, okay, let's take a break before we move on. Okay, so in the next section, we're gonna look at units digit in other number-based system. Okay, which basically has the same principle as we did in base 10. So for example, for these, you just need to add or subtract or multiply the units digit, right? And again, whenever you, so for addition and multiplication, if your result is greater than the number base, you just need to subtract the number base from it, right? Because you have to carry over. For subtraction, if your result is a negative, if the difference is a negative number, then you just need to add the number-based system, right? Because you have to borrow a digit. I think it should be pretty easy. Let's quickly go over these. Units digit 4 plus 1 is 5. It's less than 8, so it's good, right? Next, 1 plus 3 is 4. But 4, this isn't base number 4, right? So you have to minus 4. So you could say it is base 4, but but it's base number 4, you just write 1 0 or just 0. It shouldn't be too hard. For C, 4 minus 5, that's not enough. That's negative 1, right? If you want, you can actually write down negative 1, okay? But we rarely do this. We add 6 to it, it's going to be 5, because you have to borrow 1 from the previous digit, and when you borrow 1, it's base 6, you're borrowing 6. And the last one, 1 times 2 is just 2, so that's 2. Okay. Shouldn't be hard at all. I'm gonna just work it out. If you have any question, let me know. And let's move forward to this. And this idea we had covered today. A positive integer n has a units digit of 5 when expressed in base 8. What is the remainder when n is divided by 8? Anyone? This is just the idea we already discussed. Remember when we did multiplication today? Did division and multiplication today? We said that when you convert a number from base 10 to other number bases, you will do a division, right? The remainder is actually units digit. Remember, so the units digit is the remainder. So that means that the remainder here has to be 5. Okay. To be specific, let's try some examples, and you will see it. Let's say n has a units digit of 5 when expressed in base 8, right? So say that it could be, let's say, 5 in base 8, or 1 5 in base 8, or 2 5 in base 8, or 3 5 in base 8, or any other 5 in base 8, 4 5, 5 5, 6 5, whatever, okay? For all of these numbers, if you express it in decimal system, this becomes 5. This becomes 1 times 8 plus 5. This is 2 times 8 plus 5, right? And this is 3 times 8 plus 5, blah, 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 right? And this is 6 times 8 plus 5. Okay, whatever. Then for all of these numbers, if you divide by 8, these are the decimal already, right? These are numbers in base 10 already. So if you divide by 8, then obviously this is gone. This is the quotient, this is remainder, right? These are the quotients when they divided by 8. And these are the remainders. That makes sense? This is just another way to write down division, right? Remainder. Okay, so to review this, let's go over what we call division theorem. Okay, so say that you have 13 divided by 8, the quotient is 1, remainder is 5, right? Okay, remainder is 5. So 1 or 5. What this means is that this is equivalent to say 13 is 1 times 8 plus 5, which is this, see, which is 1, 5 in base 8. So the digit bundle representation of all these numbers is actually just the remainder. Sorry, just the division. Okay, 13 divided by 8 is 1, remainder is 5. It's equivalent to say that 13 is 1 times 8 plus 5, right? I think everyone should know this. This is what we call the divisor, right? This is the quotient, and that's the remainder. We all know that the dividend is divisor times quotient plus remainder. Okay, I think that should make sense. Another example, 29 divided by 8 is 24, right? So 3, remainder is again 5. And that's equivalent to say that 29 is 3 times 8 plus 5, okay? Which is this number, 3, 5 in base 8. So we see that for any number that ends in 5 in base 8, you can always express it as some number times 8 plus 5, right? So this will be the quotient and that plus 5 will be the remainder. Okay, so again, yeah. If a number in base 10 divided by another number has a remainder, then that remainder is same as a unit digit as that base number, the base 10 number expressed in that base number. Okay, I'm gonna write it down. So let's say a number A. A divided by B, we have a quotient, whatever, but if the remainder is C, okay, remainder is C, then that means we just need to say that that means A, this number, when you convert it into base B, the last digit is C, right? So it's some number, let's write down this, some digit, but the last digit is C in base B. Okay, so in other words, you could write down this. For the last digit, remember we have a notation, this, right? So A is congruent to C in base B, right? So in base B. So for now, let's just write down this. So for base B, whatever, it actually has a notation, but we'll talk about later. So now we just use this notation. Any question? This is something we have seen before today, right? Okay. This thing, so when you convert from a division into multiplication and sum, okay, into a product and sum, this is what we call so-called division theorem, okay, division theorem, 就是除法定理啊，叫做啊。Okay, and eventually you will see that recall that multiplication is to add, right? 3 times 8 is to add a 3 8 times, or to add 8 3 times, okay? 乘法就是加法嘛。And in other words, and in turn, division is to minus. 除法就是在做减法，没问题吧？所谓29除8呢，就是看29能减掉几个8呀？你减一个8是21，再减一个8是13，再减一个8是5，是不是29可以减掉3个8呀？所以29除8其实在做减法啊，得到3就是说你能减掉3次8，最后呢剩个5嘛。Okay, make sense? So to divide is to subtract, to multiply is to add. OK， 好，我们问题继续啊。Powers. Okay, we'll talk about division, we'll talk about multiplication. Okay, powers. So find the base 7 units digit. 416 in base 7 to the 416th power. Okay, so recall that for powers, we always have a cyclic pattern. Okay, so we just need to find out this cyclic pattern. Okay, and to find out cyclic pattern, you start from first power, then second power, then square, and then cube, and then fourth power until you find a cycle, right? So first, we're gonna do 416 in base 7. Well, the first power is obviously just itself, right? So that's just gonna be 6. Okay. What about the second power? So 416 squared. Notice that this is 416 times 416 in base 7. In this case, we are determining the units digit, so we don't have to do 41, right? It's just going to be 6. Remember, you only need to multiply 6, right? So we say it is congruent to 6 in base 7 squared, right? You only need to take the last digit. So you only need to calculate this. Well, 6 squared is in base 7. So when we do this, we have to convert to decimal, right? To base 10. So 6 times 6 in base 10 is 36, but this is in base 7. So that means 36 divided by 7, that's 5, remainder is 1, right? So the unit digit is 1. Okay, to make it clearer, 6 squared is 6 in base 7 squared is equal to 6 squared, right? 6 times 6, which is 36. And 36 in base 7, you divide by 7, right? You divide by 7, you get 5, and remainder is 1 in base 7. Make sense? 6 squared is 36. You convert it to base 7 is 5, 1. So that means the base 7, the units digit is 1. Okay, when you are doing this, you are doing the same stuff we mentioned here, right? You do a division, the remainder is this. Okay, you convert a number in base 10 to base 7. You are dividing that number by 7. And the remainder of the division is the units digit. 看有没有疑问啊？瑞卡，你看你想明白没有啊？大家看看想明白没有，对吧？把一个数从实进制变成其他进制的时候，我们就除以这个进制，对吧？除了这个商在前面，这个 quotient 在前面，它的余数呢就是它的尾数，就是它的这个个位数。所以我们这边可以直接得到66 36 36除7与1嘛。OK， 没问题吧？也可以怎么做呢？那36怎么知道它余1呢？那就是36减7也可以，是不是？是不是减7也行啊？因为刚刚我们说除法就是减法嘛。OK，36除以7呢，你就一直减7，很明显减掉5个7之后减到35余1，对吧？OK，so to divide is to subtract。好，OK，没问题，我们继续啊。Okay, I'll give you guys half a minute to read it.
这个是要找什么呀？
这个题目看懂，我把它写下来。那说的是arithmetic in base 11，对吧？在 base 11中做算术，怎么算数呢？说做个乘法，对吧 ？product，乘法的结果呢，unit digit 是3，没问题吧 ？And then 两个数，分别是第一个数的 base 这个 unit digit 是7，OK 吧？它其中一个数是以7结尾，乘以另外一个数不知道，最后得出来结果呢是以3结尾。问你另外一个数的这个 unit digit 是多少？
Is it 2?
Yeah, good，非常好，OK，非常好。那我们来看啊，so very good。那既然 Aaron 会了，我就中文解释一下，OK。你这边是以7结尾，你要乘一个数，你还不知道你要变3结尾，那你就试喽，对不对？因为这个是 base 11，你没办法背乘法口诀表，对吧？你只能试一下，看看谁是3。那就比如说你乘1肯定不行嘛，7肯定是7，doesn't work，right？我们把它写下来啊。So 7 in base 11 times 1 in base 11, and obviously this gives you 7 as a unit digit in base 11。OK，那就12喽。那你12的时候，2、7、14嘛，14在 base 11里面 unit digit 是几啊？那就14除11，是不是余3啊？结束了，那就是它嘛，那就是说明它是2，对吧？Okay, but any other choice? Maybe you can have a look. Okay, maybe there's another choice, right, Aaron? We don't know, so we keep going and keep trying. 这个 Lily 瑞卡还没有疑问吧？因为2、7、14嘛，14之后在 base 11里面是不是13啊？其实，对吧？14里面有一个11，还有3个1嘛。OK， and then we'll keep trying, see if we have any other answer. So 7 times 3, that's 21. In base 11, there's 111 in it, and there's a 10 in it. Right, so A. 7 times 4. So this one we don't actually write it, right? Because we say it's congruent to. So 4 times 7 is 28. Minus 22, remainder is 6. And then you time by 5 is 35. You have 33, so remainder is 2. If you time by 6, that's 42. 42 minus 33, that's 9. The unit digit is 9. If you time by 7, that's 49 minus 44. The unit digit is 5, right? If you times 8, that's 56 minus 55. Remainder is 1 times 9. That's 63. 63 minus 55. Remainder is 8. If you time by 10, that's 70. 70 minus 66. Remainder is 4. Okay? Among all, you will see that only this gives you the 3. So that means the answer is this 2. Okay, only this works. 现在没问题吧？应该整个过程比较简单，其实就是正常做个 decimal， 就做个这个decimal 的乘法，做一个这个十进制的乘法。乘完了之后呢，因为是 base 11，就除以11找 remain， 它的 remainder 就是 unit digit。最后应该很简单吧？看各位没有疑问吧 ？remainder 就是 unit digit，OK？然后 notation 呢，你可以练一下，自己写作业的时候尽量试一下用这个 notation 啊。Okay, because you will see this notation in exam. Okay, but this notation we haven't fully covered how to use it. I'll get to we'll get to that. Okay, and we'll see if we can get to that today. Yeah. Okay, so that's it. 没问题吧？我们就继续了啊 ，next section 了。OK，有问题就问一下啊。其实到现在也讲的不难啊，就是加减乘除嘛。OK，加减乘除和 power，just basic arithmetics in base 10 and also in other bases, and you just need to find the unit digit. Okay, next, unit digit, some more unit digit. This section is very important 啊，大家要做一下笔记雷里瑞卡，好吧？因为这一章呢，主要是讲的一些各种各样奇怪的数perfect square in base 4，perfect squares whatever，它们的 unit digit 在不同的 base 或者一些，它们都是一些特殊的 facts。Okay, they're special facts，and you actually get to use them when you have to prove some hard questions. Okay, so for example, in Canadian grade 12 math competition, those kind of hard competitions, sometimes you need to prove that a number might be or cannot be a perfect square. We can use some facts here. Okay, we will explain. 这些是很重要的 fact，所以要把它们记住。有时候我们要证明一个数不是一个 perfect square，比如说是需要用到这里面内容的我们来看yeah, so let's look at this. What are the possible unit digits of perfect squares? This is not hard, right? Anyone? 所有的完全平方数的个位数有可能是几呢？这个题怎么做非常简单这个只是一个 exploration. What do we do? 完全平方数的个位数。
I think, can it be any number between 0 and 1? I mean 0 and 9?
Well, we don't know. You have to try, right? So you have to go over the perfect squares, right? So what kind of perfect squares do we have? We start from 0, right? So 0 squared, the unit digit is obviously 0. 1 squared, the unit digit is 1, right? Does anyone want to continue? What is 2 squared?
4.
4. 3 squared?
9.
9. 4 squared?
6.
5 squared?
5.
5.
6 squared?
6.
36. 7 squared?
9.
9. And then 8 squared?
8 squared?
4.
9 squared? 9981, right? 1. See? That's it. That's it. Because after 9, if you go to 10, that's the same as the first one, right? If you go to 11, that's the same as the second one. If you go to 12, they're the same as the third one, etc., etc., right? And this is going to be the same. It's going to be congruent, we say. It's congruent to 13 squared. This is congruent to 14 squared, etc., etc. Okay, and then if you go to 20, 21, right? So basically, we've exhausted every number. Okay, does that make sense? 是不是看 perfect square 只用看 unit digit 对吧？所以就所有数呢，其实无非就是从0的 square 到9的 square. So what are the possible unit digit? 0, 1, 4, 9, 6, 5. Nothing else. So everything you see is not possible. It's not like every digit is possible. Only these 6 digits are possible. Okay, so we noted the possible ones are 0 and 1. We go from order. Okay, so and then 4, 5, 6, and then 9. Only these are possible. Okay, so for this you don't have to take a note because you can always investigate this by yourself, right? It's very, very easy. Okay, the special fact is not here. It's actually the next one. So let's see. Here. What are the possible unit digits of perfect squares written in base 4? Okay, so from the previous question, we've just found out all the possible unit digits of perfect squares, right? Which are these numbers. So what are these numbers when you rewrite them in base 4? And we're gonna find their unit digit, right? we're gonna find out the unit digit of these numbers written in base 4. It's not hard, just write it, right? So 0 and 1 it's just 0 and 1. 0 and 1. 4 in base 4 is 1 0, right? So we say 1 0 base 4. Which means the unit digit is 0. Okay, we'll see that later. But 5 in base 4 is 1 1. 6 in base 4 is 1 2. And 9 in base 4 is 2 1. Makes sense, right? Sorry. So what are the possible unit digits here? Oh, sorry.
Is it 0, 1, 2?
0 1 2. Yes, it is. Sorry, my bad. I got a bit confused. Not this. Okay, sorry, my bad. I read the question wrong. Sorry. So it's asking, what are the possible unit digit of perfect squares written in base 4? So we're gonna first write our perfect squares in base 4 and then find a unit digit. Okay, not just the unit digit here, but actually all of these perfect squares in base 4. Okay, I made a mistake. Here, let's put this down. So what it is asking is that we're gonna first convert all of these numbers into base 4, and then we just look at their unit digit. Okay. Sorry, I read the question wrong. Okay, so possible unit digit of what? Of perfect squares written in base 4, right? So you first find the perfect squares, write them in base 4, and find their unit digit. So in other words, we are basically just dividing all these perfect squares by 4 and find the remainder. Right? But just to make it clear, put it here. I'm gonna first just write everything down in base 4, and then we can look at the last digit, but actually just a remainder, okay? So first is 0, this is 1. 4 is going to be 1 0, right? Okay. 9 is going to be 2 1. This is 16. 16 in base 4 is, well, and ends with 0. So because it divided by 4 is 0, but it's just 4 zeros is 1 0 0, right? You can convert this by yourself, but I don't want to convert it more because we just need to look at a unit digit. For the unit digit, it's the remainder when they divide by 4, right? So 0 squared divided by 4, remainder is 0. 1 squared divided by 4, remainder is 1. 2 squared divided by 4, remainder is 0. 3 squared divided by 4, that's 9. 9 divided by 4 is 1, right? 4 squared divided by 4, of course, that's 0. 5 squared divided by 4, that's 25 divided by 4, so minus 24, that's 1, right? 36 divided by 4, that's a 0. 49 divided by 4, that's 1. 64 divided by 4, 0. And 9 squared, 81 divided by 4, remainder is 1. Okay, does that make sense? So what does this tell us? It tells us that if you have a perfect square and if you write it in base 4, the unit digit can only be 0 or 1. So in other words, if you divide a perfect square by 4, the remainder can only be 0 or 1. Okay, and this is the very special important fact here. Okay, so we say a perfect square has a remainder, okay, okay, has a remainder of 0 or 1 when divided by 4. Okay, a perfect square has a remainder of 0 or 1 when divided by 4. So that means if you have any number and you divide it by 4, if the remainder is not 0 or 1, if the remainder is 2 or 3, then this number can never be a perfect square. Right? Okay. So yeah, so in past contests, these are, when this happens, this must be the last problem. Okay, usually the last problem of any contest. Okay, the hardest question. The hardest question you sometimes, because hardest question can be any aspect, right? But it might ask you to prove a number or just a number in that question to prove that it is not a perfect square. To prove a number is not a perfect square, one of the most common methods is to divide it by 4 and find a remainder. If the remainder is 2 or 3, then that number cannot be a perfect square. Okay, but usually that number is in algebraic form. It's actually, sometimes it's it's like something with x and whatever. We'll talk about that in the future. Okay, but for now, just note this fact. A perfect square, when divided by 4, must have a remainder of 0 or 1. Okay, I should change to must have. Must have. Okay, so in other words, a perfect square when written in base 4 must have a unit digit of 0 or 1. They're the same, okay? Having a unit digit in base 4 is the same as to say having a remainder of 0 or 1 when divided by 4, right? So this is equivalent to say a perfect square must have a, so remainder can be changed to unit digit. Again, of 0 or 1, and this part, when divided by 4, is the same as written in base 4. Okay, guys, get it? Okay, just make a note, remember this. And if you forget, you can do this, right? But if you have never learned anything like this, if you have never got to know this kind of idea, you will never be able to, well, to really to study this or to find this out in a math exam, right? In the math competition exam. So yeah, I remember there was a 1 year Euclid, so Canadian grade 12. The last question was to prove one of the numbers there to not be perfect. Okay, prove that number is never going to be a perfect square. And in the official solution, it actually says that a student can know that a perfect square must have a remainder of 0 or 1 when divided by 4 by exploration. Then how can you even know this, right? In an exam. And even if not an exam, I give you a month, you probably won't be able to find this out, right? So this is kind of a famous fact. So, that's why you need to remember this, okay? All right, if that makes sense, let's move on. Let's look at the next one. Okay, this is good, I think. All right, okay, next. This is not a famous fact, it's just a very easy question, okay? What are the possible unit digits of n factorial where n is a positive integer? Possible units digit of a factorial. Factorial is a product from 1 to that number, right? So shouldn't be hard. We start from 1, right? 1 factorial has a unit of 1. 2 factorial is 1 times 2, so 2, right? 3 factorial, 2 times 3, 6. Okay, if you want, you can write down 2 factorial times 3, so 6. 4 factorial is congruent to 3 factorial times 4. 3 factorial has a unit stage of 6, right? So it's congruent to 6 times 4. And eventually it's 24, so 4. Okay, and just when we think it's not gonna end, you will see that starting from 5 factorial, it's just going to be 0, right? 5 factorial is 4 factorial times 5, and that's 4 times 5, which is 20. So the unit digit is 0. And ever since you just have 0, because you have a 0 now, right? So for example, 6 factorial is going to be 5 factorial times 6. 5 factorial has a unit digit of 0. You're gonna have a 0, and ever since you're gonna have zeros. Okay, so the possible unit digit here is 1, 2, 4, 6, and 0. Okay, make sense? For any question like these, possible unit digit of something, then you just do just a little bit of exploration on your own. Okay, you'll see some pattern. You always see some pattern. Okay, unit digit is a very fantastic, amazing aspect of math. It's very, very amazing. Yeah, there were a lot of patterns coming from it. Yeah, and you will see that this entire branch of mathematics is never covered in school math. Okay, as we said, number theory is never learned in school math. It's kind of difficult. Okay, next question. Some word problems. And I'm gonna ask for ideas, okay? So you guys can read the question first.你看能不能读懂题啊？读不懂的话呢，我给你解释一下。
我觉得他说的是对的。
你这是对的，你看懂题了是吧？那为什么是对的呢？
能看懂。就是如果就是他说那个把那个5列出来嘛，那然后呢列出来digits of 5 1 5的5 3 5 15 5 25 7 35 9 45，那它都是1 3 5 7 9，那么5不包含，那就1 3 7 9是多少
1 3 7 9是多少？3 7 21嘛。
1 3 7 21 9，
是不是9？
89。
你看 unit digit 不用算10位数对吧？就是3 7 21就1乘99对吧？
对，那either 5或9。
Very nice, good. Okay, very good, very good. Okay, so let's see, Lily, Aaron, if you guys have the same idea. Okay, so 4 consecutive odd integers, right? And the unit digit is 1. So basically, this question is just another way of asking, what are the possible unit digits when you multiply 4 consecutive odd integers? Right? So for odd integers or consecutive odd integers, basically they end up with 1 or 3 or 5 or 7 or 9, right? We don't need to look at tens or hundreds digit, whatever, because we are only looking at the unit digit, right? So the unit digit of any odd integer are going to be either just either one of these. Okay, now just one of these, right? So for 4 consecutive odd integers, the possible scenarios you could have is these 4, 1, 2, 3, 5, 7. Let's write it down. So 1, 3, 5, 7. That's one possible scenario. Or you could have 3, 4, 7, 9. Or you could start from 5, 5, 7, 9, 1. But for these 3, obviously the unit digit is going to be 5, right? Because there's a 5 in it. 5 times whatever number, since they're odd, it has to be 5. If 5 times any of a number, an even number, it's going to be 0, right? 5 or 0. So these 3 are congruent to 5. Meaning that for these 3 scenarios, we have a unit digit of 5. The only one we haven't covered, the only one that doesn't have a 5 in it is that you start from 7, right? So 7, 9, 1, 3. For this is basically 7 times 9 times 1 times 3, right? 7 times 9 times 1 times 3. So you do 3 times 7, 21. So 1. 1 times 1 is 1. 1 times 9 is 9. The unit digit is going to be 9. Okay, so the product of 4 consecutive odd integers can only have unit digit of either 5 or 9. So not 1. So this is impossible. So 3D is right. Yeah, he's right. That's it. Okay, very good. Very good. Very nice. Any question? Good. Next. Problem. Okay, let's go one by one. Question A, if m is a non-negative integer, what are the possible unit digit of this? 2 times 3 to a positive power. What can we do? We explore, we try, right? Make sense? Throughout this section, you will see that we always
I think
try.
I might have the answer for A.
Mhm.
It's an even number, so I think the unit digit will have to be 2468 or 0.
2468, I get it. You think this can be 0?
Oh, no. It can't be 0 because it's a multiple of 3.
Yeah, there's no 5 in it, right? To get a 0, it has to be 2 and 5. Yeah. So you guess it's 2468, but we have to verify because it might be skipping one number. Maybe it's only 248. You know, you will never know, right? So we try. Okay, we're just gonna try. It's not hard. So for question A, we do 2 times 3 to the 0th power. That's going to be 2. So we have a 2 here. 2 to the first, 2 times 3, that's 6. Right? 3 squared, 2 times 9, that's 18, so 8. 3 cubed, just times another 3, right? 8 times 3, 4. Times another 3, right? 4 times 3, 2. Done. So we start to see a cycle, right? Because you go back to 2 again. So 2 times 3 is 6, 6 times 3 is 8, 8 times 3 is 4. And 4 times 3 is 2. A cycle. Okay, so it turns out, yeah, we do have 2, 4, 6, 8. Okay, very nice. What about B? So B, B is 4 times 3 to a power. So it's not just gonna be 2, but it's going to be 4. So basically, we just need to times this by another 2, right? If it is 2 squared, so 4. So 2 squared times 3 to the power of m. These are just one of these times 2. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2, 16. 6. 6 times 2 is 2. Same. Same for the same for possible units digit. Okay, and then C for 6. Well, for 6, it's not really different from question A, right? Because for 6, you can factor out the 3. So it just becomes question A. Make sense? So 6 times 3 to the mth power, that's congruent to 2 times 3 times 3 to the mth power. So it's congruent to 2 times 3 to the power of m plus 1. So just it's the same as question A. So it's the same 4 numbers, okay? Still 2, 4, 6, 8. Okay. For question D, you will see that it's the same as question B, because for the question D, it's 8 times 3 to the power of m. So that means it's just, on top of question B, you time another 2. So that's no different from, time another 2 from A, because they have the same numbers, right? So it's the same as question B. Okay, that makes sense? So 2 cubed times this, that's just gonna be congruent to 2, 4, 6, 8, same. Okay, Rico 知道我们要把 D 讲完了。Okay, very quickly. So eventually we're actually doing E. Okay, we're actually doing E. How many of the positive divisors this have a units digit of 6? So 6 to the power of 2006, you can, the hints here is to factor it to 2 and 3, right? So it's actually 2 to the power of 2006, 3 to the power of 2006. Okay, and you can, based on this pattern, because you're looking for their positive divisors, right? So the positive divisors here can only be 2 to a power times 3 to the power. The power can be any number between 0 to 2006. This can be any number from 2006, right? And you will see, you're going to study what numbers can give you a 6, and then you can determine the answer. Okay, I see Rika has already found the answer. Yeah. Very good. Okay, so yeah, okay, Rika, you can go. Yeah.
Bye.
Okay, so we have to study what kind of situations do we have unit 6 of 6 or a remainder of 6. So you have to study pattern here and stuff. Sorry, I also have class later, so I couldn't do this. So you guys can read a textbook, see if you can make sense of it, and we can continue next time. So basically here is that you just have to study the pattern, okay? Try to figure out what kind of patterns, what kind of powers gives you 6 here. Like for power, so because the divisor has to be in a form of 2 to the 8th times 3 to the bth, right? So try to do some explorations on your own by doing these, and then try to find out what A and B have to be, like what A and B have to satisfy in order for you to have, well, a unit digit of 6 here. And then after you find out the criterion, you will be able to find out the number of choices here, the number of choices here, and multiply them, and you can find out a total number. The total number is around 1 million something. Okay, so give it a try, and then we'll continue next time. Okay, so see you.